Keep going. 7, domain and range. So the domain of a quadratic is, so mind you, this is set notation and interval notation, right? And I will just say this changes with word problems. And I can't emphasize this enough, okay? So this is only the case if I just give you a graph and you see arrowheads on both ends of the arms, then yes, you can say that the domain, just to clarify, this means that all x values are permissible, like all values in the real numbers are permissible, or negative infinity to positive infinity, because if you think about it, right, a parabola, whether it does this or this, it will keep spanning and keep expanding forever, right? So all x values are implied, okay? So that's where the domain is basically, if there's no word problem attached to it, this is just it, okay? So range is a little different. Range, right? If it opens up, then it would be range is y would be greater than or equal to maximum. Sorry, I'm getting this wrong. This is minimum, folks. I'm just looking at it, doesn't make sense, right? If it opens up, there's a min. So let's redo this part. My bad. Or you'll write it like that. If it opens down, and the range becomes y is less than or equal to max. And notice how there are square brackets and round brackets, right? Infinity always gets a round bracket, okay? So I'll give you some examples here. So just sketch, okay? You don't even have to use a ruler for these ones. So let's say you're at somewhere in this neighborhood here, and we just go up slowly like that, and you try to replicate that here. Okay, so let's say that's your curve, and you've got that this is -5, -3. Okay. My domain in this case is just x belongs to all real numbers, because the arrowheads indicate that this keeps on expanding to the negative x values and positive x values, it never stops. So you need to choose one, okay, and stick with it. Range, in this case, it opens up, right? So if you think about it, you look at the y value -3, and then it goes up after that, right? So in a sense, if you're going to think about it, y is going to be greater than or equal to, because it's included here, -3. And this is the minimum, right? This is the minimum. We would consider this a minimum here because it's the lowest point, right? It's not the equation of the minimum, it's just the minimum point here, which is still the vertex, right? So it's essentially, right, the y value of the vertex. Or you could also say you're starting at -3 and then you're going to infinity, because the interval notation, remember, you always start with the lowest and then you go to the highest, okay? So there we go. That would be that. And I'll give you another example of the opposite, right? So let's say you have, try to make it a little smaller, right? So let's call this 7, 4, the coordinates of the vertex, and then we go from there, like that. So here my domain would not change, but my range would. Okay, so think about it this way. 4 is you were looking at the y values here. The 7 doesn't really matter right now for domain and range, but 4 is the highest y value that you're getting, so y will always be less than or equal to 4. Study sheet material, right? Or how would you do this part? Well, you're coming from -infinity, right? You're scanning and you're reaching a high of 4. And so that's how you do your domain and range. A quadratic equation will only ever have y-intercept, so that stays the same. But the x-intercepts are the ones we're not sure of, right? The constant c, right, determines the y-intercept. But note, this only applies to the standard form. It has to look like this. Only if it looks like that can you say, okay, that last number is my y-intercept. Okay. And that's the one we're going to start with, and later on I'm going to introduce you to different ones. Okay, so example, f of x is equal to -2x squared plus 3x minus 4. Okay. I'm going to do this because I always forget to do that. But if I ask you determine the values of a, b, and c, if I give you something like this, You need to be able to tell me what those are, and it's not, some students would say, A, it's negative 2x squared. That's not A. A is only referring to the coefficient in front of x squared, so it'd be negative 2. B is the coefficient in front of x, so it's positive 3. C is the constant on its own, so it'd be negative 4. Right? The y-intercept is 0C. Therefore, this little triangle with 3 dots is called therefore. It's 0, negative 4. For this particular, the graph that would result, if you entered this, would give you a y-intercept of that. Did I put a square bracket on negative infinity? Somebody's saying that I did that. Ah, good catch. Who was that? Cedric. Okay, hold on. What's before the r in the equation? That's an E, yeah. That's a Greek letter. I'm gonna go. It's a Greek letter. It means that all the x values belonging to the set R, which is the set of the real numbers. So E is just like a, is it epsilon or something? It's belonging to, right? So it's a set notation. You should have seen this in IPR. I might be wrong. I'm pretty sure when I teach it, it's there. So yeah, that's just a symbol. It looks like an E, but it is curved, right? And yes, Cedric, you caught it, right? This is not right. So that's supposed to be a round bracket. Good catch. Fix that, please, because that's not an infinity should not never have square brackets around it. Okay. Okay, we're good. All good. All right. What I want to do quickly, we're doing baby steps here, okay? Because I don't want to dive in and then you're all lost on me with a calculator. Can you go ahead and type that in? Just type in this equation into your calculator. Okay, so y equals, so negative 2x squared. I'm using the x2 button for when I square x, okay? Plus 3x minus 4. You want one? And if you remember how to use it, but I know you were in my class before, so okay. So let's enter that and graph it. Hit graph. And I think Zoom 6 will give us a better view. Oh, maybe not, but there it is, right? It's there. How would you find the x-intercept, the y-intercept? Sorry, not the x-intercept, because there is no x-intercept. See that? No x-intercept. How would you find the y-intercept again? We would go second, trace 1, x is equal to 0, and there it is. It is negative 4, just like we just wrote down here. So let's say you get some weird quadratic that doesn't look like this. You can always find the y-intercept using your calculator, okay? Because you are going to see some bizarre equations down the road. Use your calculators, okay? And you'll find it every time. All right, that's it for characteristics. Oh, do I have room for that one? Yeah, I will add this. So another example, y is equal to 2/3 x squared minus 3x. Okay, what would be my y-intercept in this case? The y-intercept, a is 2/3, b is -3, c is 0, right? So this would be 0, 0, because c, right, the c value is technically there. You just wouldn't bother writing it down, right? So it's there. So maybe I'll just do -4 here, use that color, and use the 0 here, just to make sure there. All right, so let's do some practical, like this all was a lot of, concepts, theories, and whatnot. So let's do some practical stuff now, okay? So we're gonna graph. Okay, so graphing a quadratic function. On paper, I should say. Okay. Before we do that, we're gonna always have to determine a whole bunch of characteristics. We're gonna draw them out of the graph. We can draw them out of the graph, or we can actually come up with them using our calculator, right? Okay, so the normal characteristics that I would like you to write down, and I'm gonna give them to you, okay? So you don't need to memorize these. So you're gonna need to know the vertex, you need to know the max or the min, okay? You need to know the axis of symmetry. I'm gonna ask you to tell me that. The x-intercept or the x-intercepts, okay? You're gonna have to find the y-intercept and the domain and the range. One second here. I thought last year I had added another one for students to try, and I'm just gonna look at my notes from no, that's it. Okay, we're good. Okay, so these are the characteristics. So there's 2, 4, 6, 7 of them that I'm going to ask you to figure out. So let's graph something on this side here. Sketch it. We're not really graphing. Okay. So I'm going to come up with a. So if you could do 1, 2, 3, 4 to the right, and 1, 2, 3 to the left here. So 4 units right, 3 left. We're going to go 4 units down. Just space them so that it fits. Okay. 4 units down, 4 units up. This actually goes against what I always talk to you about. Use a ruler. So I'm gonna try to fix that. Okay. So go 4 this way, 4 up, 4 down, 3 this way would be fine the way I'm gonna give you the equation here. So we're gonna go, maybe I should let you finish this grid first before I start giving you the graph. All right. 1, -3 is where we're going to start with our vertex. Okay, so we're going to call out 1, -3, label it. And before we actually graph our parabola, I'm going to ask you to label this 3, 0. So we're going to go up here, right? And we're going to label this one -1, 0. This one here. And now that you have 3 points, which by the way is the minimum number of points you need for a quadratic, okay, to be able to graph it. So then you gotta become, this is like an art, okay? So you slowly start, you curve, and then make it go past, but don't go straight up, not like a U. You keep expanding it and try to copy it on this side. And this actually goes right through here, folks, through 0, -2. So I have to build a lot of knowledge before I can start giving you more homework. So I'm banking on it, just so you know. All right. So 1, -3, that's my vertex here. So that's what they're asking for under vertex. So if I ever gave you a graph like this, I would probably not label them. I just did that so it's easier for us to graph, but you just go and find the coordinates of the vertex. Okay, so it'd be 1, -3. These two will most likely be separate. Like I'll put a min and a max line in there. You just have to tell me which one corresponds to this graph. In this case, you only have a minimum, right? You never have a max because this just keeps going. So you circle the one that is the case, and it's an equation, right? So it's y is equal to the y value of the vertex. So you write it down like that. Axis of symmetry is also an equation, and it's x is equal to the x value of the vertex, right? It's going to go right through here. So you've got vertex, and the vertex gives you this, and it gives you that, okay? The x-intercepts, you have 2, -1, 0. Please write them down as coordinates. Regardless of how you did it in IPR, write it down as coordinates. So coordinate 1, coordinate 2. My y-intercept is obviously 0, -2. My domain, you can use this squiggly brackets it is, okay? Or -infinity to positive. Don't write both down, just write one of them down, okay? What would be my range in this case? It's pointing up. So there's a low point, the lowest point, and then it goes up from there. So y is always going to be greater than or equal to -3. Squiggly brackets, or you start with -3 and you go to infinity, positive, like that. So I could give you a graph. You're supposed to extract that information, the characteristics of it, that way. So graphing using the TI-84. No. Let's see now. Graphing. So it doesn't matter if it's y equals or f of x, right? Enter it into y1 and use second trace to determine the characteristics of the parabola. Okay, so example 1, that's graph 1. So we have y is equal to negative 2x squared plus 10x minus 12. And we're going to point up or down. I'm going to ask you that just now, just to practice that. Is it narrow or wide? Is we're going to do vertex, min, slash max. We're going to do the axis of symmetry, X-intercepts, Y-intercept, domain, range, and let's write down our window. I think we need to practice that as well. So before we're even going to start graphing, I'm going to first analyze and see what am I to expect. So I kind of want you to always go through this, even though you're not always going to have to write all of this down. Like all these pieces are in play here. So how would I go about graphing it? Can I even imagine what it's going to look like? Okay. So first of all, does this one point up or down? Just look at the value of a, and it's negative, so this would be pointing down. Is this one going to be narrow or wide? Well, a is bigger than 1, so we're going to expect this to be narrow. Okay. And the rest, we're going to use our calculators to do that. Okay, so the first two here, you could have done that without a calculator. Now we're going to use our calculators to do the rest. So let's type that in. Negative 2x squared should already be there, right? Because we've done that just now. So I'm just going to scroll along and then go plus 10x minus 12. So the only time you use that negative button is for the leading coefficient, and then the rest is just plus or minus, okay? And let's hit graph. And there it is. Okay. Now, if you look carefully, if you look very carefully, I'm going to try to bring it closer, right? You can see that it crosses the x-axis twice. It may or may not be clear. So if you press zoom 6, you should see the exact same thing that I'm seeing here. If you wanted to see a bit more of this area right here, we could zoom in, right? But we're just going to leave it like that for now. Here, the y-intercept, we can't really see where it's going to cross it. So we're going to change our window a little bit. So we're going to go window. We're going to change the y-min to, let's say, negative 20. And then you hit graph. And now we can see that, and we also see those two. It's a little hard to see. So hang in there, okay? Stay with me here. Look at what I'm going to do to address this here. If you wanted to see more, if you notice here, all of this is basically empty space here that your calculator is displaying. All right. You technically only need to start, if you started at like -2 or -3, right, which is right about here, then you would already see the whole graph as is. So we're going to go to our window and get rid of all of this and just have our x min be at -3, not -10 the way it is right now. So go window, change your x min to -3, and then hit graph again. And now you're seeing a little bit more everything that the graph is really what you're interested in terms of the graph. If you wanted to see more, you still see that all of this is empty space, right? So you can kind of tell that if you had your y max set to like 5 instead of 10, because right now it's set to 10. Let's split that in half to just have 5 here. So window, y max, we're going to change that to 5, and then we're going to hit graph. And it's still somewhat hard to see, but we're just going to leave it at that, okay? But you should be able to see that it's crossing it twice. Let's go ahead and find our vertex, okay? The first thing we're going to do is find our vertex. Here you have to pay attention, okay? We're going to go second, trace, and you have to pick between min and max. What do we have in this case? We have a maximum, right? Because it's the curve goes up and reaches a maximum, so you have to pick the right one. So we're going to pick maximum. Hit enter. And watch what it says. This is our reference point right here. This is the vertex we're after. It's at the top of the curve. What is it asking you for? First question. It's asking you, I don't know why they can't just write the whole thing in, but it's asking you for a left boundary. It's basically asking you, give me a point to the left of the vertex. Give me a point to the left of the vertex. So go left, keep going left with your arrow until you go past that vertex. This is pretty obvious that we're now past and we are to the left of the vertex. Hit enter. Now you're going to go to the right. It says right boundary. See down here? We're going to go to the right. Past the vertex, over to the right of it. Once you're to the right, you hit enter. And notice you will see two lines like this. So you've told the calculator that the vertex is somewhere in between those two lines. And it's going to find it for you. So whenever it says guess, remember, you just hit enter. And there it is. It says that the maximum is at 2.499 and something. So we'll round it to 2.50. So watch what I'm going to do here. Second, trace, and we went max, and then we found that it was 2.50, and it's 0.5 for your y there. So you've found that. Once you have the vertex, you can answer these two just by looking at the coordinates of your vertex. So we have a max, obviously. So y is equal to 0.5. For the axis of symmetry, it's x. X is equal to 2.5 or 2.50. And so the vertex answers these two things right off the bat. No calculator needed for these two. You just need to know how to get them. Okay. Now your x-intercepts. How would you find the x-intercept before? We go to y equals. We let y2 equal to 0, just like we did before. You hit graph again. And there's that line going along the x-axis and cutting it twice. So we're going to find the left one first, and then we're going to find the right one next. Okay, so we're going to go y2 is equal to 0. Second, trace 5. We're going to do the same thing we used to do for our linear equations. Okay, so second, trace 5. We're going to go over to the other side. Watch. I'm going to go past it, and I'm going to go closer to the one that I want to find on this side. And then it's basically hitting enter 3 times. So enter, enter, enter one more time, and you get 2, 0, right? 2, 0 as your intersection there. So we'll write it down, 2, 0. But there's another one that I see, right? On the other side, you have to do the same thing again. Second, trace 5, move over to the other side. I'm going to go closer past it just there. You just don't want to make that it mixes them up. Okay, so here we're definitely going to hit that first one there. Enter, 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 and we are at 3, 0 there. So 2, 0 for the first one, 3, 0 for the second one. Does it work for you? Yeah? Okay. Okay. My y-intercept, you can just go look at this and just write down it's 0c, which ends up being 0, negative 12. And if you don't like that, just use your calculator, right? Second trace 1, x is equal to 0, it will give you negative 12, just like we did before. Domain, I'm just going to stick with this one, easier for me. Range, what would you put for range? Let's look at our graph, maybe that will help us. This is the highest y value reached, so y is less than, y is going to be less than or equal to, and there you just go look at your vertex. It's going to be less than 0.5. Okay? So y is less than 0.5, or this one I'm going to do both, right? You could say negative infinity all the way to 0.5, like that. And my window, I'm just going to copy the values that I have essentially. I used negative 3, 10, and I used negative 25. So x min, x max, y min, y max. Okay. And before we go, I'm going to show you how I would sketch this. So I'm going to sketch it right over on this side. So you have to be smart about your scale. Okay. So I'm looking, and it's not a really big scale, right? I'm not spread out a lot. Like my X-intercepts are 2 and 3. I do need to account for negative 12 for my y-intercept. Okay, that sounds good, Charles. So I need to account for negative 12. So I'm going to go negative 3, negative 6. So I'm basically using a scale of 3 here, like that. But here along the x, I'm going to use 1. So 1, 2, 3, 4. That's already too much, but hey, why not, right? So 1, 2, 3, 4, 5. If I label that one, it's telling me that this is 5. So I'm going to go x and y. Don't forget your x and y labels. So this would be 3, 6 here, right? 3, 6. And here we go 1, 2, 3, 4, 5, negative 5. So I'm using a scale of 1 along the x. I'm using a scale of 3 along the y. Let's go and plot our points, right? So 2.5 would be right about here. 2.5 and 0.5 is right about there. 2, 0, which is my x-intercept, is here. 3, 0 is there. And then 0, negative 12 is here. So then you take this vertex here, right? And you just go through that x-intercept and then go through the y-intercept and then just keep going like that and try to copy it over to the other side as best as you can, right? And label 0, negative 12, 2.5, 0.5, 3, 0, 2, 0, and last but not least, my equation, the equation itself. So that's how you graph it. Okay. So what I'm going to do is just give you a couple to try on your own. I have a worksheet, but I don't want you to use it yet. Okay. So we're going to give you one here. Try this one. So homework, try this, right? So it's going to be y is equal to negative 1/3 x squared plus 5x minus 9. So we're going to call that A, and then B going to give you y is equal to 7/8 x squared plus 50x plus 15. So for both of these, you do the exact same thing that we just did before. Okay, you come up with all of these characteristics for A, you graph it, and you do the same thing for B, and then you graph it. Okay, it's very important that you start practicing, and the video is there, right?